Um, this question is asking um, for the volume of a solid with a circular base um, um, that has a radius of r and square cross sections that are perpendicular to the base, right? So the cross sections will obviously have sides that correspond to the chords that I'm drawing here, right? So infinite chords that will be equal to the sides of the cross sections, right? Like that. So our goal is to um, find the length of these sides, and on top of that, to find um, uh, so obviously by finding the length of these sides, we need to find the values of y in each point on this circumference. And you know that the volume of the circle is equals to x squared plus y squared is equals to r, right? And then so that means that I'm going to put y in terms, so I'm going to put the formula in terms of y, because y is going to correspond to half the sides. Remember that y is here, so if y is here, if for example I have y here, and then I will also have another y at the bottom that is equal to negative the y at the top, right? So the side is going to be equals to this total length here, which is equals to 2y. So you're going to say y is equal to r squared minus x squared, and the side length of the squared of the square, so the side length of the cross section square is going to be equals to 2y. So that means it's going to be equal to 2 square root of r squared minus x squared. This is s, right? And you know that the area of a squared is equal to s squared, one side squared. And we're saying we want the volume of the whole solid. So that means we want an infinite sum of all of the cross-sectional shapes. So all of the cross-sectional squares from this point to that point here. And this point, you know that it's going to be r, because you know the radius of the circle is equals to r, and that point is going to be negative r. So you know, every time we add up infinite, if we add up um, um, uh, something infinitely, the typical notation to use is either Riemann sums or integrals. So we're going to, the easier one to use is this one. So we're going to say we're going to evaluate the integral from r to negative r, right? Um, the integral from r to negative r of s squared dx, right? And you know that s squared is equals to 2 minus 2 times square root of r squared minus x squared dx, right? And this is going to, so remember we're saying squared, right? So we need to square it like that, which is going to be equals to that 4 r squared minus x squared dx. And then you evaluate this integral here. This thing is a constant, r squared is a constant, so it's going to be equals to this. And then this one, if it's a squared here, then you know that you're going to add 1, and whatever is going to be the exponent, you divide by it. So you have this, right? And then this is going to be equals to r squared. You substitute r minus 1 over 3. You substitute r again, right? This is for the first bound, and then for the second bound, it's r squared. Substitute negative r, because the other bound is negative r, minus 1 over 3. Substitute negative r to the 3. Get this, right? And this is going to be equals to basically you can already tell that this is going to be equals to twice r to the 3 minus twice r to the 2 over 3 to the 1 over 3. So you are going to have 2 minus 2 over 3, which is going to be equals to 4 over 3, right? R to the 3, yeah, and that is going to be equals to 16 over 3 r to the 3. But you know that this is the area. Okay, I think it's right. Yeah, so this is the answer.